Okay, this is assignment number 9 due March 17, 2026. You're asked to download an STP file which represents the geometry that you see on the left side and get rid of these two holes here and change the radius of these side fillets to 15 inches from what you see. And once that is achieved, then perform a finite element analysis for it where the bottom faces of this piece on the extreme two end sides are clamped, and this pressure of 100 psi is applied to that face. Now, uh, for the purpose of the homework, I don't expect you to do the symmetry, but towards the end, I'll come back and repeat that or redo that problem for you where symmetry is applied. And yeah, so let's go ahead and get this thing. File, open. Here's my STP file. Uh, let's see now, fit this thing so that we can see things. Just a couple of comments. It's a good idea to have a roughly an idea of what these sizes are. For example, if you look at this radius is right now 5, okay? We want to change that to 15 later on. And now, there's two options that you've got. One of them is to go and defeature these two holes, and that can easily be done. There's no problem. But when it comes to uh, uh, defeaturing these two fillets, there's going to be a problem because first of all, if you defeature, that's okay if you can manage to do that, but then you have to come back and fillet of radius 5 there. But one thing I wanted to point out here, if you go to fillet filter, notice that it gives you a message saying that the fillet range is between 0 and 3.93 inches. I just found out this was 5. So definitely this is asking for trouble because what it's seeing is that this should be the range of the fillet. 3 is fillet radius 0 to 3.9, but this is already 5. So you're welcome to go ahead and do it with defeaturing this, but I'm not going to do it like that. Let me cancel this. Let me go ahead and parameterize as much as I can. So I go to the automatic or manual, it's the same thing. Remember, this is the message that you get. It says that, hey, if you want to do this, your solid part must be in work object. So expand this thing, select that part, the dump solid, define in work object. Now it is there. Now you go either do automatic or manual, but I'll do automatic. So uh, everything, and let me select the faces. That makes everything basically. Make sure you select them all. And hopefully it can completely parameterize, but it may not happen or it may not be worth it. As long as you can make the changes that you want, that's good enough. I think I've selected everything here. And then say OK. There we are. Now, notice that it did not. This doesn't look good. That's okay. That's okay. Let me do the following. Let me go ahead and put this thing in, uh, make it in work object. So there we are. Now, as long as I can change the stuff that I want, that's fine. For example, what are these? This is a hole that I want to delete. Right click, delete. Okay. The other one is this hole is there. Delete. Fine. Now, where are these fillets? Edge fillets, I want to make this thing 15. 15. And the other fellow, the other one is there. 15. Good. Please note that this is not completely parameterized because these things are left, and this is why you got that weird shape. You got that weird shape. But as long as I can do what I want, this is good enough. I don't have to parameterize everything. All right. Now we're going to apply material to this, which is steel, default properties of steel. So I'm going to go and select steel on the part. Then we say okay. Good. That's pretty much it. So now we're going to go to analysis simulation, generative structure analysis, static analysis. Let me change the rendering here. Good. Now you're asked to, if you want to look at your mesh, put the cursor there, right click mesh visualization. Good. Now if you want, you're asked to do local mesh refinement around the hole, around this hole. So let me deactivate this. All right. And use the go to model manager. You see this? This one says local mesh size. You select that. And I will use, for now, I'll use 1 inch, see if it looks good. Otherwise, we say make it smaller. Say, okay, let's look at it right now. Activate the mesh. So notice that around the hole, we have a finer mesh. Now, if you're not happy with these meshes, and you really should not be because this is too coarse. This mesh around the fillet is too coarse, but I'll leave it the way it is because I just want you to do it according to my instruction because that's what you have to do on a test, okay? Let me deactivate that. Good. Now, we're going to clamp the bottom of these. Not, it's not a clamp. Clamp see if we put it, clamp this face and that face and say okay and apply a pressure on that face 100 psi. You type in 100 psi here and then before you run always save the stuff because in the event that you made a mistake, you put a very small element number, very small local refinement, this may take forever to run. So let's go to a file, say management, analysis, save as, this is homework, so I'll make a folder here, homework 9. Put the stuff in this folder. Analysis goes in that folder. Propagate directory, so it puts my part in that folder too. Good. Now, let's go ahead and run it. So, run, compute. And it's done. So if you look at the deflection, it looks like that, which makes sense. Yeah. These bottoms are fixed. This is applied to a pressure, subject to a pressure. If you look at the von Mises test, for example, it looks like that. Change the rendering to material shading. And the very fact that things look kind of patchy here is an indication that you don't have a fine mesh around these fillets, these fillets. Incidentally, if you want to see the elements here too, you go to this uh, last one in the rendering, last one, and notice that the elements, if it's not checked, check edges on points. There we go. You can see that. Good, good. Now, oh, by the way, what kind of element am I using? I'm using parabolic, which is fine. But I already told you there is a problem here and there's a problem at these corners because there should be finer mesh in those areas. But garbage in, garbage out. Now, let me deactivate this. Okay. So, if I want to use symmetry, I can do two things. One is to just save everything first of all. All right. And close that. So there is the the part that is already saved. Okay, so what I'm going to do is I'm going to cut this thing into half and then save it again. Okay, we can use a plane. We need a middle plane. Do we have middle plane here? Let's see now. Let me see what I have here. YZ. Yeah, right there, middle plane. Okay, I do have a middle plane here, right there. You can see that. If not, you go create. So we're gonna go split with this. Doesn't matter which side you pick. Good, good. So let me go ahead and save this thing. File, save management, save as. Uh, Let me go up, make a folder here. I'll call it homework 9 with symmetry. Okay, say okay, save in there, and then say okay. Good. Now we're going to go to generative structure analysis. That's fine. Let's go ahead and apply local mesh refinement. That's what it was. There, I'll put 1 inch. That's okay. Let's look at the mesh. We don't have to look at it, but if you want to see it, you can. Right there, you can see this. Right, very good. Deactivate that. Now, the bottom of these are still clamped. This is clamped and this is clamped. Do not forget to put surface slider on these fictitious planes surfaces that you have created uh, to count for symmetry. So surface slider on this and that, and then say OK. And finally, apply a pressure 100 psi. Do not divide 100 psi by 2 because if this was a force, if I had the total force, then you divide it in 2, but not pressure. And then you say, okay, now before you run, you save this analysis. File, save management, analysis, save as, in the folder with symmetry. Save, propagate directory so that everything is saved separately. The full model is saved there in a different folder, H9, homework 9, and the half model is saved there, completely independent of what you did in homework 9 with symmetry. Okay, so let's go ahead and run it. Don't worry about that. If you look at the deflection, there we are. You can animate it if you want. Without that surface slider on the side, garbage, it's just garbage. I mean, you lose points. It's a garbage. The very fact that these are patchy tells you that you don't have a fine enough mesh in these areas of importance. And yeah, well, I didn't ask you to do it, so don't. Incidentally, remember the local mesh size is right here. You can see that. This was the original mesh everywhere, and this is the local mesh that you specified 1 inches. All right, folks, so let's save everything and we check to see if our work is saved. So here's the situation. Let me close this and close that. I'm completely out of stuff on my screen. I go to that folder right here. Notice that I have 2 folders. One of them, homework 9. This is the one without symmetry. If I double click on it, let me maybe have to open it. File, open, homework 9, this one. This is the one without symmetry. Is it there? Yes, it is. Now, if I had to mark this on a test, because you did not save the results file, that's okay. What I'm going to do is I'm going to run it and check your work. Oh, actually, it's right there. Okay, good, good, good. That's good. Let me close that. No. Now let me go to the other fellow with symmetry. That one. Okay, so let's go and open that. So file, open, not homework 9, but up homework 9 with symmetry. And I open it. There we are. Okay. This way, there was no danger of you losing either one of them, etc. Let me close that. If I look at the model, that's this with symmetry. Half of it is going to pop up. Good. On the other hand, if I look at the other fellow, open, up, homework 9, this one without symmetry. Oops, it's already open. Let me close that. File, open, homework 9, this one without symmetry. That's it. And good luck.